Hi everyone, I'm here with Armando Fox, professor of computer science at University of California, Berkeley, right? Mm-hmm. You are also a diversity and equity officer advisor. You're also a musical theater fanatic and performer.
Yep.
And aficionado of computing history and retro technology. You are on sabbatical until December 25.
Correct.
And you teach Introduction to Software Engineering, assessments for mastery learning, teaching techniques for computer science. You have a nice webpage with news, a blog.
Fortunately, it's mostly up to date.
And this musical theater performance, Cantos de Mi Terra. There's a webpage there. But what else can you say about you? Who are you? What do you teach at Berkeley?
Who am I? I think you got most of who I am. I was one of these kids who started playing with computers pretty early. Maybe I was in 6th or 7th grade. Of course, we're talking about the 1980s. And when I went into computer science, it wasn't a particularly glamorous field. It wasn't a field that people went into because they expected to make a lot of money or for financial security. It was a good field, but it wasn't the field that it would become in the 1990s and 2000s. So I think a lot of my experience in how I approach teaching computer science, I tend to seek out students who remind me of myself at a younger age, who are really excited about the intellectual challenges of computing. They're also gratified by the idea that you can use computing to help other people solve their own problems. And I have been doing music since, when I could walk. I grew up in New York City. I was born and grew up in New York City, and my parents always went to the theater, went to the opera, and so from a very young age, I learned to appreciate the musical arts. And I grew up seeing Broadway musicals, and now I have the privilege of once or twice a year, I work with regional theaters in the San Francisco Bay Area, usually as music director, and I'll probably end up doing musicals forever. So I think that's who I am. And I ski and scuba dive.
Oh, wow. That explains a lot, because New York City is the place where nowadays people see Brazilians go to New York City to watch musical theater performance on Broadway. And unfortunately, I was born very close from here. We are in Recife during the Brazilian Congress of Software. And in my city, there are no musical theater performance. But now, where I live, sometimes in Curitiba, they have some performances.
Well, after I retire, maybe I'll start living in other countries and try to produce musicals there.
Okay. Here in Brazil, I believe São Paulo and Rio de Janeiro are the cities where most people go to watch.
That would make sense.
In my city, it's very rare. I know there was a Wicked performance a few months ago, but only those very famous
ones, of course.
Yes. You mentioned to Fabio Con, who helped us to have this conversation here, that you have classes with around 700 students.
We have classes larger than that. I would say in our department, so computer science has been a very high demand major at Berkeley, one of the most popular, and a medium-sized class in computer science could be 150 to 200 students. Large classes could be 500 to 700 students. And actually now, data science, which is a new major only in the last 5 years, has become the most popular major on campus. Data science classes can have 1,000 students. So everything we do at Berkeley, we have to do at scale. About 10 years ago, 12 years ago, along with my colleague David Patterson, Berkeley was one of the first universities to launch massive open online courses. In fact, one of the ones that we launched on Agile Software Engineering was based on and inspired by the course that I teach at Berkeley. And it struck me that even at the time we did that, Berkeley had been dealing with scale in the classroom environment for quite a long time. So we had some ideas about how to have an online course that could have thousands of students. But I think that experience really made us do even more of some of the things that we were already doing. So for example, we have always relied heavily on automatic grading, auto grading, we call it, automatic evaluation of students' work. And I'm not talking about just sort of simple, multiple choice questions or fill in the blanks questions. Auto grading of full stack web applications, auto grading of equations, and now things like proofs. So going to a massive open online course made us really lean into those methods even more. We had already had at Berkeley kind of a lot of our classrooms were already set up to automatically video record the lecture, the PowerPoint slides connected to the computer, and we had this whole automated pipeline where within 24 hours, that material would become available to all students. So, when we say we have a class with 1,000 students, what lecture hall is large enough for 1,000 students? None of them are. But some students who prefer to come to live lecture are able to do that, and a lot of students will be able to then watch the videos after the fact. So a lot of the techniques of scalability, when people talked about massive open online courses, we already had some experience in doing those, and we have just deepened our investment in some of those technologies. And it takes a fair amount of effort to build systems like that work reliably and that students can actually get quality feedback from, but it pays back very well. In fact, you mentioned that one of my roles, my service roles, is diversity and equity, which is very important to us at Berkeley. And I'm sure you've seen similar issues here in Brazil, where when students arrive at university, they could be coming from a variety of different socioeconomic backgrounds. They have not all had the same level of access to computing education, maybe at the high school level. And so they arrive with different levels of preparation. And because of that, some students may take longer to master some material compared to other students. And we think everybody that we admit is smart enough to be able to do it, but they may not necessarily always do everything at the same rate. So a few years ago, with my colleague, Professor Dan Garcia, we became very interested in mastery learning. The idea that if you give students a lot of opportunities to practice, if you give them high quality feedback that is near instantaneous, and you combine that with a little bit of time flexibility, both in when they can take their exams and when they can submit homework assignments, lab assignments, and things like that. Benjamin Bloom showed in 1968 and later in 1984 that combination of ingredients can really narrow the gaps in student achievement that are coming from uneven prior preparation. So the good news is we already had some of these ingredients. When we invest in automatic graders, we think of auto graders really for evaluation, but even more importantly, the auto graders provide immediate feedback, which is also valuable when the students are doing homework assignments, to immediately know what they got wrong. We can give them an infinite number of attempts to submit the homework, and TAs really just step in to do the actual teaching. So I think for us, part of the benefit has been that the teachers of the course, which is both people like me, the professors who are instructors, but also our student teaching assistants, student TAs, on whom we rely very heavily, we are able to spend our time with students actually explaining things and sitting down with them to understand where their conceptual obstacles are and things like that, instead of spending time manually grading everything. So that's been a huge benefit. In the last 3 or 4 years, as we've invested more time and more effort in really going deep on mastery learning, we've, I think, made even some further improvements to some of our processes. For example, we've started to use this open source framework that we really, really like. It's called Prairie Learn. That's Prairie Learn. And that's because it was developed at the University of Illinois, which is in the American Midwest. And the landscape there is kind of a prairie landscape, praderia. We think that it's, as instructors, we think it's one of the best tools of its kind for authoring assessments, both exercises and exam questions, that are not only authentic, they can be very rich. Anything that you can do in a browser, any kind of interaction you can do, writing code, dragging and dropping, interacting with a full stack IDE, anything like that can be turned into an exercise and a question. And the auto graders for those questions can do anything they want. We're experimenting, and others are also experimenting, with using AI to help us do sort of first passes of auto grading. So the ability to use this system, one of the things that it gives us is, instead of creating just a question for a homework assignment or a question for an exam, we're creating a generator that can create on demand many different variations of the question. So that gives us two very important advantages. First of all, for the students who want to practice, they can keep generating different variations of the same question and keep practicing, getting instant feedback every time until they feel like they are confident with the material, and then that material will be on the exam. The other thing it gives us is when the students take the exam, each one of them will get a slightly different exam because the question variation is part of the exam. And this turns out to be really profoundly important because it means not all of the students have to take the exam at the same time. In other words, we don't care if students who take the exam early are telling the students who take it later, there's going to be a question on joining database tables. We will tell them what the questions will be. We want them to practice the questions. We want them to get the feedback. We want everybody to succeed. My colleague Dan Garcia calls this A's for all, meaning we don't have to change the bar, the criteria for getting an A, but we can give everybody the opportunity for as hard as they're willing to practice for everybody to achieve that level of success. And I think a reason that this helps us with scale in particular, when you have 700 students or more, an exam in the traditional way can be very difficult. You need to find room for all of those people to take it at the same time. Maybe some students will get sick and then you have to reschedule them later. Maybe some students will be traveling. They'll be going to an interview. There's a million reasons why some students may have a conflict with the exam. Some students maybe have a learning disability or a health issue and they might need some extra time on the exam. And so you have to manually keep track of all of that. So we were thinking if we can give students some flexibility and time on when they take the exam, now we can spread the exam over several days. Students can decide when it's best for them to take the exam. Maybe they can spread out their exams so they don't have 3 exams on the same day. Maybe if they're traveling or if they don't feel well that morning or if they have to deal with a personal or a family-related issue, now it's not a problem anymore. So an essential ingredient for managing scale is to allow that kind of flexibility without creating a lot of work for the instructors and for the TAs. And of course, if we can do that, then there's no reason we can't also give the students flexibility in turning in lab and homework assignments. When I was in college, a standard practice was if you don't submit your homework on time, there's a penalty. Maybe the first day you get minus 30% and the second day you get minus 50%. And if you think about it, the problem with that is if the student has to make a choice between losing points and learning, they're always going to choose the points. They will find some way to get the homework in on time, even if they don't do it all themselves, even if they don't really learn from doing it. And so that works against the goal of mastery learning. So most of our computer science classes at Berkeley have now moved to having no penalty for late submissions, because if the submissions are largely auto-graded, it's not really additional work for the TAs. And we have built an open source tool, which we call Flextensions, for flexible extension, where students can just use a Google form to indicate, I really need an extra day or 2 on this assignment. And in many cases, they will get immediate automatic approval. Our tool will then update the LMS so that when the student submits the assignment, it will not be marked as late. They won't lose any points for it. If the student asks for too many extensions or an extension of a very long time, the system might say, you need to meet with a TA first, maybe over Zoom, because we want to make sure nothing's wrong. We want to make sure there's not a problem that's going to impede your performance for the rest of the class. In fact, we have had students come to us and tell us, this is the first time that a professor called me into their office not to give me a lecture, but to ask me if I was okay, to ask me if there was anything wrong or if I needed support. So I think finding ways to manage some of these things at scale to make the hard things easy. Giving exams used to be hard. We have now a computer-based testing lab. Again, we're following an example that Illinois has been doing for many years very successfully. We have computer labs where the computers are pre-configured. They're locked down so that students don't have access to unauthorized resources on the internet. Students make an appointment on a calendar. They show up at the time of their appointment. They take the exam. The software knows if this is a student who usually needs extra time, it will give them extra time from the moment they start. If the student has to cancel and reschedule their exam for any reason, it's fine. So the other important element of, if exams become easy to administer, another thing you can do that works very well for equity and diversity is instead of a few very heavy exams, you can have a larger number of shorter exams. For example, instead of having 2 3-hour midterm exams, you could have a quiz every week that's 1 hour, or a quiz every other week, and then maybe a final exam. And this is a great idea for many reasons. First of all, there's a lot of research showing that retention of knowledge is better if you're being frequently tested on it as compared to if you're just passively studying it. So more short quizzes exercises your brain to retain that content better. And we see that because the final exam scores go up. Students are actually doing better. At the end of the class, they retain more. The other reason that it works really well is it's a lot less stress for the student if, there's a 1-hour quiz every week or every other week. Each individual quiz doesn't have to count that much toward their grade. If the entire course has 2 exams and most of their grade is based on 2 exams, then what you're really measuring them on is how are they doing on that particular day, instead of a more global measure of how much they know for the entire class. And if your exams are, traditional method, everybody at the same time, then it's even worse because they have to take the exam at a specific time, whether that's a good time for them or not. So I think that, I would summarize fast feedback for students, investing heavily in auto grading, and I think now with AI, we're going to see what are the limits of AI for auto grading. We don't think that AI will replace instructors for this. They won't replace teaching assistants, just like we thought that online courses are not going to replace interaction with instructors in a university setting, but I think it can increase our productivity a lot. So we're trying, and it feels like we have a double win because not only are we handling scale better, but we're doing it in a way that's better for the students.
Yes, and it seems to me that it's not something that is extremely expensive. You have to have a lab where the students can go and take the tests. So
yeah, and in fact, I would imagine it's a similar situation here in Brazil. Most of our students, the vast majority of our students, have their own laptop. And so when they do coursework, we don't really need computer labs very much anymore. We have a few labs because there's special software that the university licenses and it's only installed on some computers. But for the most part, our computer labs are not as essential as they were, 20 years ago. So we've been able to convert some of the computer labs from being instructional facilities to at least part-time being testing facilities. And in fact, the university has, over the last 3 or 4 years that Professor Garcia and I have been working on this, the university has realized that this is actually, even though it began in computer science, these practices really should be adopted across all the departments in the university. And so they have committed to spending a substantial amount of money to create a full-time, about 100 seats testing center that will be located in the center of campus. We already have faculty from many other departments outside of engineering and STEM who are using that facility, and we're getting more and more demand. So we're really happy to see that some of the things that we began doing in computer science, both for scaling and to make students' lives better, and honestly, faculty's lives also better, are now in demand enough that we're starting to see adoption in other parts of the university. To me, that counts as success, as having impact beyond your own borders.
And this methodology, is it used only for courses in the first years, or?
No, not at all. In fact, the software engineering courses that I teach are typically for students in their 3rd year and some who are in their 4th year even. And that was one of the first courses to pioneer some of this technology at Berkeley. This semester, our upper division data science inference course, Data 100, I think has over 1,000 students this semester, and they are moving to this model starting this semester as well. So we use it both in our introductory courses and in our advanced courses.
Yes, and I believe it solves a problem that for us professors, lots of professors all around the world are worried that students are going to use ChatGPT to solve their exercise lists. Yes. But in your methodology, it's useless for the student. He's going to need to learn to take the test by himself or by herself.
Yes, it's actually part of the goal is, students can spend energy trying to figure out how to cheat in this controlled testing environment, but our hope is that they'll realize it's going to take them less time to just learn the material than to figure out how to cheat on the material. But I think it's interesting that you mentioned LLMs and ChatGPT. Of course, we worry about students using them in an irresponsible way, right? We don't want that to substitute for the students actually struggling with the material and learning the concepts. At the same time, as a software engineering instructor, students who are graduating in the next couple of years in software engineering will be expected to know how to use AI responsibly as part of their job. And so we're thinking a lot right now. In fact, part of my time during my sabbatical is to think carefully about what is a principled way to introduce the use of LLMs and other AI technology into software engineering so that students use it to become more productive rather than thinking that they can just sort of lean on it and have it do all of their work for them. I think it's an intellectually exciting time, but I will say that I think a lot of the fundamentals of software engineering are only going to become more important, not less important, as a result of this.
Exactly. And as you mentioned, I'm one person. I know there are many persons all over the world that are worried about the ethical issues regarding LLMs. First, most of the big LLMs companies are in the US, and also it's kind of not well known, but they like to say that they need lots of energy, lots of water, and also that we don't know, for instance, the most famous one, ChatGPT, we don't know which data was used to train that. So how do you deal with that when you are using LLMs in your course, in your research?
Sure. One thing I will say, my colleague David Patterson, who co-wrote the Software as a Service textbook with me, he's now spending some of his time post-retirement working at Google, and they just did a pretty interesting study on energy usage of AI training and AI queries. It's worth a read, but one of the high order bits is that you should be more worried about the energy involved in replacing your phone every 2 years with a new model, right? The embodied energy cost of the world's mobile devices that are being used to access AI is actually much larger than the energy cost of running it. Now, I'm not saying that we shouldn't have to think about this. We should be worried about it. But I also think that in some sense, and I think there are ethical issues with what data was being used for training, what biases are inherent in that data, was the proper permission obtained to make sure that that data can be ingested. I feel like we're at the point with LLMs, and I'm not an expert on this, where we're in the sort of initial hype and excitement phase. The large language models are doing things that are truly remarkable. The generality, the fact that you can basically ask any model any question and for the most part expect something reasonable back, it is astonishing. But I do think that as the technology starts to mature, it will probably become much more specialized. If you think back to sort of post-industrial revolution when electric motors were invented, right? The motor, it's going to run everything. The problem is nobody buys a motor. They buy a device that has a motor in it, right? People buy, I hate to use the cliche, people buy a solution. They don't buy a technology. So I think as LLMs start to become specialized for different tasks and different domains, I think some of these problems will be assuaged a little bit. You don't need the world's smartest, the world's largest model if what you're doing is having a coding assistant or if you're answering questions within a specific domain. So I think some of that, we have to sort of wait for it to shake out, right? I think it's a little early to make predictions about all of the big companies are in the US and they will be forever, and US AI will run the world, or maybe Chinese AI will run the world. These are all concerns, but I think it is a little premature to declare defeat on those things. But it's also important for the students to understand that these are issues, so when they're using AI, even understanding that the answers are not foolproof, that AI makes a lot of mistakes. I've talked to software colleagues, quite experienced ones, who have tried to use it as a coding assistant, as I have. Sometimes, it saves you a lot of time in figuring out the answer to a question where the documentation isn't clear or it's difficult to find a good example of the code you want. Other times, I have spent an hour going around and around trying to get some code that shouldn't be that hard, and for whatever reason, the LLM can't give me a working example, and I was like, this didn't save me any time. I should have just looked on Stack Overflow. I should have read the developer documentation more carefully. In fact, I gave a talk here yesterday at the LATAM Software Engineering School, one of the points I raised is you're increasingly seeing experienced developers have the same reaction where, sometimes if you know exactly what you're looking for, if you know exactly how to ask the question, you can often get very good results and save time. If not, you can actually end up wasting time because you'll get, even if it's code that is correct, it might not follow the conventions of your code base. It might have security holes. It might have other vulnerabilities. Basically, you have to clean it up, right? You're creating technical debt faster than you can sort of pay off that debt. And so you have to be very careful putting this code into a production system. If you want to use it for a prototype or to explore an idea or to build a very quick demo, that's one thing. But increasingly, software runs the world. And we have to be able to place some trust in what the software is doing. And developers are finding that, who are the developers who are benefiting the most, I think, from this are the ones who are already experienced. Because the way that you know exactly what to ask the LLM is you yourself have design skills. You understand software architecture. You have built systems before. So you have a pretty good idea in your head of what you want, and you sort of want to get this junior developer to help write the code for you. That's very different from someone who's not experienced, doesn't have a good sense of design, doesn't understand the fundamental architecture of the system that they want to create or the system that they want to enhance, and so they don't know what to ask for. And they ask for something that is not, what they get back is not particularly usable, and they may not even have the skills to recognize that it's not particularly usable. So I think, in some sense, the good news, if we can call it that, is I don't think LLMs are going to eliminate software engineering. On the contrary, I think some of the most important parts of software engineering are going to become even more important. The ability to think about design and evaluate trade-offs, the ability to work as part of a team that has a diverse skill set, the ability to look critically at code and design because the code is going to be in the code base long after you have left the company and someone else is coming on the project. Those are actually the skills that we emphasize in teaching software engineering courses. Writing the code is not the bottleneck step in software engineering. And so I think now that's just going to become even more true.
You co-authored the book Engineering Software as a Service, an Agile Approach Using Cloud Computing with David Patterson. And this book was translated into Portuguese, which is great because many Brazilian students can't learn books in English. I'm going to say it in Portuguese, Construindo Software como Serviço, SaaS, uma abordagem ágil usando computação em nuvem. It was translated by Fábio Com.
It sounds so good when you say it,
He's a professor at MOOCs, and Daniel Cordeiro. What's this book about? What feedback did you get from students, professors, teachers, instructors?
Sure. So the book came about when my colleague Dave Patterson and I, he was my senior mentor, a very successful computer scientist. You probably learned architecture from his book. I think most computer science students have heard of him for that reason. We had just taken over the software engineering course at Berkeley. We had also, as I mentioned earlier, we had launched a massive online course that was based on the same material. And we were not happy with the popular textbooks available for software engineering at that time. At Berkeley, we're very fortunate to have contact with industry, very, very frequent contact. And we had contacts in all of the major software as a service companies. And the textbooks that were mostly being used to teach software engineering did not match the modern agile techniques that most of those companies were using. And so we sort of decided if there isn't a good book, why don't we create one? And the timing was good because if we were about to do a massive open online course that could have thousands of students, if we made the book available, that would be a way to get feedback very quickly on the book. So that's how it came to be. And we wrote it based on not only our experience as instructors, but in close contact with our industry colleagues who gave us a lot of feedback, both positive and negative, and made sure that what we were presenting really was reflective of the modern practices for building software as a service. I would say that the book has held up very well. It was very well received by students, certainly very well received by some of the companies that would be in a position to hire students with these skills, basically saying, thank you for presenting a realistic, hands-on, lots of programming projects that really capture and let the students learn how to do these techniques in a classroom setting. So I think we've been very happy with the reception. And I will say, it's now more than 10 years since the first edition of the book came out. We've made a lot of revisions. There's a second edition. But I think the content of the book has actually held up very well. I know that when we started writing, we made the choice, the book is not about programming. It's about all of the other things that go with programming. It's about design and teamwork and how to talk to a non-technical customer and how to create a plan for designing and implementing what the customer wants, estimating how long it will take. That's really what the book and the course are about. But of course, you have to pick some programming language and framework in order to present those ideas. And software as a service seemed like the obvious choice. It was the way that software development was going, so it was sort of future-oriented at that time. I mean, now everything is software as a service, right? With a mobile client, which again, it's turned out to be a very effective way to do software, is a mobile client app plus a piece that runs in the cloud. We had made the choice to use Ruby and Rails as the framework that we would use for teaching. And basically our position for that, and we had a lot of people, especially students, because students always want to learn the latest thing. At the time, the latest thing was, I can't remember which JavaScript framework, probably Node. And then a few years later, it was React, and then it was something else. And what we would tell the students is, look, what we care about is these are fundamental concepts in software engineering. We think that this language and this framework do a particularly good job of exposing these concepts in a way that makes them easy to learn and easier to put into practice. After this class, if you never write another line of Ruby in your life, I don't care, because I want you to be able to apply the concepts to any new language and any new framework that you have to learn for a project that you get assigned to. And I think if you sort of, if you sort of look at the Google sphere and ask, how is that language and framework doing? Is it still popular? It's actually held up very well. And I think increasingly people are seeing with modern HTML, modern CSS, everything has to run on a mobile device, that in fact, the design choices embodied in Ruby and Rails are holding up extremely well. And the students are able to pick it up relatively quickly. They're able to apply it. And as I said, I think with the advent of LLMs, the fundamental things about software engineering are still going to be important. In fact, they're going to be even more important. So the fact that the book does give code examples and you build apps using this framework as a way of practicing the principles, but the emphasis of the book is on the principles. And I think those principles are going to stay stable for quite a while. So we're pretty happy about it. It was also translated into Spanish. It's been translated in Chinese, Greek, and part of my sabbatical is also thinking about, as I mentioned before, what is a good structured way to introduce the use of LLMs responsibly into this process, and what should we be doing both to the curriculum and therefore also to the book. So maybe next year, you can look for an update.
Great. Regarding diversity, because you live in California, I know, or at least I think that in considering all the states in the US, California is one of the most diverse regarding race, right? But we also have a problem, I believe, all over the world, but here in Brazil, it's very huge, the gender diversity. I mean, I'm part of a group, this podcast is part of a group, Emília's Armação em Bits, where we try to attract more girls and women to CS.
We have the same concern. And I think, so let me go back to what I was saying before about mastery learning and why it's beneficial and why we've invested so heavily in trying to bring those techniques. And you asked whether we do this also in advanced courses or only in the introductory courses. And the answer is both. But in the introductory courses, there's another important role that has to be played that is maybe even more critical. If you're coming into an advanced course or into an introductory course, maybe it's your first exposure to computing, or maybe you look around and you see a lot of people who aren't like you. They're not the same gender as you. If you're a woman, you don't see as many women as you would in a general population. If you're of a particular ethnic background, maybe you feel like there's very few people. In this large class, there's so few people who I think are like me, right? So that leads to the risk that those students have more difficulty feeling a sense that they belong there. And that difficulty is compounded if they start having difficulty with the homework assignments, the exams. After a while, what they might say is, well, the problem is that people like me don't belong in this field, don't belong in this class. I don't have the necessary skills or talent to be successful at this. And then they leave the major. And so indeed, the good news at Berkeley is that if you look at our introductory classes in computing, the what I'll call the diversity statistics, and that applies both to ethnic, socioeconomic, and gender, look pretty good. But then as you get into more advanced courses, it starts falling off. So we're doing a better job of attracting people to try computer science, in these introductory courses, but we need to be doing a better job of retaining them. We need to make sure that the experience they have in those introductory courses is an experience that tells them, you belong here, you can do this. And if sometimes all it takes to make that difference is to give them a little more flexibility in timing, more opportunities to practice. My colleague Dan Garcia, who's the spiritual leader of a lot of this, he's even instituted techniques in his courses where if you take an exam and there's some questions you do poorly on, those questions might show up on a later exam in the same class. And if you get them correct the second time, it eliminates your bad grade the first time. Because his view is what we care about is not what the students know on Thursday, October 1st. We care about what they know by the time the end of the class comes. In some cases, he's even allowed students who were in danger of not doing well in the class to say, I'll give you an incomplete grade for the semester. Incomplete grades are sometimes used, for example, if the student has a sudden personal emergency that prevents them from finishing all the work in the class by the end of the semester. And so Professor Garcia will say, I will let you have extra time going into the next semester to make up the missing work that you haven't been able to do or to retake an exam, because it's more important to give you an extra 2 or 3 weeks so that you can be successful. So he's really going all in, and especially in his introductory courses. He actually just received the highest teaching award that UC Berkeley offers. He's already won every award that the department offers, but now he has the university one. And this year he was also named as the Carl Karlstrom ACM Outstanding Educator Award. And I think what he's doing in this area is really exceptional. And I would say if any of my Brazilian colleagues are thinking that this is something that could be useful in your university, please check out some of our work and contact Professor Dan Garcia, because we would love to see more schools really leaning into that. And you can do it. I mean, with the tools and automation, we've shown that you can do it, and you can do it at scale, and it's actually better for everybody.
That's great. So my next question is not a technical one. It's regarding musical theater. I entered, as I told you, your webpage. There's what's exactly, it's Cantos de mi Terra. What's that?
Cantos de mi Tierra, yes.
Cantos de mi Tierra, sorry. And what's okay. Your role in it?
Sure. So Cantos de mi Tierra, which in Spanish translates roughly as songs from my homeland or songs from my country. There's a lot of Latinos in California, as you can imagine. And there's also a lot of Latinos who enjoy music and perform. And so there's a group of us who met because we would always go to the same piano bars. And they had been talking about putting together, they said that there's probably an audience for songs in Spanish that reflect different parts of Latin American culture. So I'm Cuban American, although born in New York. One of our lead singers is from Mexico. Our other lead singer is from Puerto Rico. And we play, music from the Caribbean, music from South America. And initially we thought the audience might be primarily Latino people. It turns out a lot of people who are not Latino are very interested in the music and the culture. So it's not just a program of songs, although we do play songs, but we also explain why was this composer important. For example, we just did a show very recently around Gay Pride weekend. Pride is a big thing in California. And as part of that show, we were selecting songs by Latino artists who were queer or who were gay, and who at the time they recorded those songs, in their country, it was sort of very difficult to be a queer person. And so we talked about, listen to the lyrics, that, what they're saying is this, but what it really means, if you know how to read it, it's kind of a code for this. And, some of these artists, once they became internationally famous, then they could come out and proclaim who they were because, they were sort of too successful to be taken down. But we try to provide an insight into the culture, the artists, as well as just singing the songs. And it's been a great deal of fun. So we have actually another show coming up in just a couple of weeks for that. And then, of course, the musical theater part of my life. Musicals are one of two musical forms that are really American in origin. The other one, of course, is jazz music. But musical theater not only was it invented in New York, really, New York, I would argue, is the only place it could have been invented, because it's really kind of the hybrid of two forms, the sort of operetta form, which comes from Europe originally, but also, New York had a lot of immigrants, and the immigrants generally arrived without very much money. So they are not going to go to the opera. So there was a market for entertainment that was targeted at an audience that was kind of a popular audience. They maybe weren't highly educated. They weren't accustomed to going to things like the opera. So it tended to be more comedy. And there were a lot of, honestly, there were ethnic stereotypes. And, yes, you're Italian in New York, and you're seeing this guy on stage who's making fun of Italians. But by making fun of you, he's also including you in society, saying you're a part of this bigger mix now. So, and if you look at the history of American musicals, there's a lot of musicals that comment on the kinds of issues that only arise in a multicultural society. So I think, people think of musical theater, they think of Wicked, or they think of Grease, like these shows that are fun. And there's a lot of that, Song and dance is entertaining. I have nothing against it. But there's also musicals that tell very serious stories, but because they can use music as an additional ingredient, in addition to dialogue, maybe they also use movement, dance, as an additional ingredient. To me, that combination is more than the sum of its parts. So I've always loved doing musical theater, and I'm sure, people say, are you going to be bored when you retire? And I'll just do more musicals.
Well, great.
And if you find yourself in the Bay Area, you should look me up, and I will comp you to any musicals that I happen to be working on while you're in the area.
That's
real
great.
Offer.
As I told before, I didn't have musicals in my city, but I like to watch musical movies from the 40s, the 50s.
Yeah, the golden age.
Yes, the pirates singing in the rain, some very famous ones. So now the last question is something that I don't expect you to predict the future. Maybe you can say something that you want to happen or that you think it's going to happen. What's the next frontier in software engineering?
You're right. I shouldn't predict the future, but I think in some sense the next frontier in software engineering is kind of the frontier that we have always had, which is as software becomes more and more critical to running really everything in the world, as we start to rely on it for more and more things, what has been the goal of software engineering up to this point? It's to have code that is trustworthy, that is reliable, that we can make good statements about where the data that is being used by that code is coming from and what problems might be in that data, whether it's issues of bias or issues of data corruption or lack of data provenance. Basically to make sure that software is serving us and not the other way around. Now, there's a lot of non-technical aspects to software serving us and not the other way around, right? The surveillance economy and things like that. But if you're asking about what are the technical frontiers of software engineering, I think in some sense our goals are the same as they ever were, but now we have a powerful new tool that, if it's used responsibly, could help us make better progress toward that goal. I've seen exciting work from people who are using LLMs not only to help with coding, but to help with software testing and to help identify security holes. Like, there are things that are difficult to do, and now we have one more tool. So I don't think that there's never been every sort of 10 or 15 years something comes along in software engineering that this is going to be the magic bullet that solves everything. And so people who have been in software engineering for a while have stopped believing that any magic bullet exists. But at the same time, I appreciate the value of a new tool, and I do think that Gen AI is a game-changing and fundamental new tool. The challenge for us who work in the field is to figure out what it means to use it responsibly. So I think our goals and frontiers for what we want software to be, what we want it to do, haven't changed. I think we have to figure out what is the best way to use this new technology to help us make even faster progress towards those goals.
Thank you very much, Armando. If people want to learn more about you, there is your website, armandofox.com. I was also browsing Spotify. There's an interview with a professor from Duke University from 2020 about MOOCs.
Oh, was that Kristen Stevens-Martinez, maybe? Does that sound familiar? The interview was with me.
Yes.
Yeah, she was actually my PhD student at Berkeley several years ago. She's now a professor at Duke. So it was a real pleasure to do that interview with her.
Okay, and if people want to collaborate with you or want to do a PhD with you, what should they do?
I'm always open to receiving email. I think people ask a lot, I want to do a PhD with you. It doesn't really work that way in the US, right? You have to apply, it's competitive and so forth. So I'm not making any promises about when or whether I'm taking any students anytime soon. But I would say, think about, why would you want to do a PhD with me? Presumably it's because I work on things that are interesting. A lot of people work on these things that are equally interesting. So I would encourage people to sort of broaden your question and say, at the end of my PhD, what does success look like? What is the thing that I want to do that will change the practice of computer science for the better in some way? And I am happy to give people advice on, if we don't work together, where else or with who else they could work to further their own goals.
Okay. Thank you very much.
Thank you. It's been a pleasure. I appreciate being on the interview.
Bye-bye.
Obrigado.